Hello, I'm Ashit Baran Chakraborty. I'm here to present my one of the projects that is based on CNN, that is convolutional neural networks, and I basically design and tune the deep learning models and for their optimizing their performance and impact of various hyperparameters. Okay, so like test ratios, activation function, pooling, dropout, so it initialize the learning rate, these all kinds of things into that model and how we can improve the accuracy of the brain tumor of the detecting the brain tumor. So in this fourth section, glioma, meningioma, pituitary and no tumor, we have divided the uh, tumor and we have designed a model such a way that we can design a code. This is our architecture. So these are custom made architecture where we are gaining one of the greatest highest accuracy, that is about 95% of accuracy. So we have used three convolution layers followed by three max pooling layers, and later I also compared the max pooling with the average pool, so that we can extract the maximum accuracy from that. And so after that three max pool, we have I have used that flatten layer, and after the dense two dense layer, and here we can use the top max as the activation function. In the internal segment we use the ReLU. So these are our results through graphs where we are getting a test accuracy of more than 95% and 95.3. So let me show the code. So here are the codes in the GS code. We have opened that. So these are libraries for that we have imported. So later these are the directory content. That's a pituitary, non-tumor, meningioma, and class. With four subcategories are presented in the directory. So here we created that images and labels. These two empty list, and iteratively from that path from the base directory with that category that join the path, and from that in the image section we are appending one by one edge in of that subcategory, and the associated label or associated category with that image is appended here in the label list. So by we can get I can get that that levels after loading the image glioma, and all the pituitaries are last at the first there are glioma, and in between that there are meningioma and not pituitary. So unique levels and their counts are also presented here. And after encoding, we have encoded it for our mathematical and purpose for training the model. So using NumPy, so these are the numbers. So after that, we have displayed each of that category of tumors and the distribution of the images. And next is for the different test train, and this is our model, custom model. And as time is not that much sufficient, so I am not going into that much of detail. And here are the train test ratios, and for each ratios here are the samples of training and testing, and for each epoch we are getting the test accuracy. So after getting test accuracy, we are getting here that maximum test accuracy is at the 70%. But as the loss is minimum in the test, loss is minimum in the 90 to 10 ratio, so we do further work like different kinds of uh, activation function changes and all the pooling of all of these hyperparameters during on this 90 to 10. So this is also a significant amount of 94.76% of test accuracy. So For further, these are the classification reports and the contribution max frequency here. And after that, here, same normalization and the standardization of all the three frequencies here. But here we are creating our again a custom CNN model where we are experimenting with dropout, activation, and pooling. So combining, we have the combination of 2 to the power n, that is 2 to the power 3, 8 combination, where dropout, where somewhere is true, somewhere is false, activation somewhere is ReLU, somewhere is sigmoid, and in case of pooling also max pooling and average pooling. So we are showing the result here, and we can see here that max pooling with so ReLU is out from the sigmoid as is expected, as the because of the gradient descent problem faced by sigmoid functions, and the max pooling is slightly better than average pooling, that is extract the most efficient features out of the data. So these are the rules, and again we have created some of the uh, hyperparameter tuning with the weight initializers with K normal and global uniform, and different kinds of learning rates. So here are the results. So I cannot show the graph here, but these are the results. So this is about this brain tumor detection project. Okay, so now I will show you another project. As the time is limited, I will not go into the details. This is also made by CNN, and this is also on the medical imaging. And this is a pneumonia detection project from here was the brain tumor detection from the MRI of the brains, and this is the from the chest X-ray we can detect the pneumonia. And I also develop a uh, Flask-based web app for the convenience of the end users and the physicians or radiology. So here is it's running. So this is the link. If we open or click that link, so additionally, I can say you that I have also designed a architecture and uh, do some hyperparameter tuning with RNN and LSTM also. There also I work with some of the RNN data and measure some of the hyperparameter tuning using the our custom RNN and LSTM, and all the how the sequential data works and how the model is designed in this process. So this is also another process where I predict the Google stock price in a certain period of time, where I use this my custom RNN model, and this is the actual Google stock price. This is the LSTM predicted, and this is the our RNN prediction. So RNN prediction outperform here in the in this case. Okay, so I also did some of the hyperparameter tuning here with different kind of activation, and I am measuring the RMSE for different types of configuration where units are different, 50, 100, 150 and 100, and dropout rates are different, and activation functions are different. So this is also another project, the RNN versus LSTM and comparison between them, their prediction and model hyperparameter tuning, the RNN configuration and hyperparameter tuning. So and there I get some conclusion that RNN LSTM is more sophisticated and preferred long-term memory than recurrent neural network for the stock price prediction. But here RNN outperforms the LSTM. So it's a matter of research that where RNN and how RNN outperform the LSTM. This is a surprising fact. So now I am showing that link, that is, yes, this is the Flask web app where pneumonia prediction system. So I choose the chest X-ray from my local file. Okay. Yes, these are the test vectors. So I choose the test data. First, I choose the pneumonia one. So now I'm checking if this person has the pneumonia. I'm picking it from pneumonia. Yes, prediction pneumonia, confidence 99.45%. So it gives the correct prediction that pneumonia is, and I choose from the pneumonia. So now I am now choosing from the test case of the normal case. So anyone from here now the prediction. It's predicted normal with confidence of 77.9. So we have to increase the accuracy also. This has the accuracy of 86%, I think, this pneumonia prediction model. But in case of our brain tumor detection model, we hit the accuracy of 95%, which is impressive. So we'll working on it. So to better build the models, to use the ResNet and all these transformers, all the updation and innovation happens in this field. Okay, thank you for showing interest in my project.